The Filly and the Whale. The story of one revolution. The Dzhevetsky Submarine of 1881 and the birth of a new era at sea. Prologue. A voice from the abyss. September 22nd, 1914, 6:30 a.m. The English Channel, the armored giants of His Majesty, the cruisers HMS Aboukir, HMS Cressy, and HMS Hogue, were slowly plowing through the cold morning swell with their stems. They were confident in their power. Thick steel sides, massive guns, the training of thousands of sailors. All of this seemed like an unshakable bastion of the British Empire. But somewhere in the gray depths, at periscope depth, a steel, cigar-shaped eye was watching them. Inside a small, cramped compartment, smelling of oil, sweat, and fear, 28 men held their breath. Their ship was laughably small compared to the monsters sailing above. Its displacement was a mere 500 tons compared to the many thousands of tons of the armored cruisers. It had almost no armor. Its weapons were just 2 cigars attached to its sides. The commander of the German submarine U-9, Captain Lieutenant Otto Weddigen, estimated the distance one last time. He turned a handle. Compressed air hissed, pushing the torpedoes out of their tubes. Several minutes of agonizing silence passed. Then the morning air was torn apart by a monstrous roar. A column of water and fire erupted against the side of Aboukir. The armor, riveted by Britain's finest shipyards, burst like an eggshell. Thousands of tons of water rushed into the ship's belly. An hour later, it was all over. 3 cruisers lay on the seabed. 1,459 British sailors had embarked on their final voyage, and the small, wet, exhausted U-9 crept back to base on its way to becoming a legend. That day, the world understood what 33 years earlier in Russia, one strange Polish engineer had guessed: the future of the fleet belongs not to those who sail on the waves, but to those who know how to sail beneath them. This story is about that very engineer, his wooden submarine of 1881, and how a small marvel of technology initiated the great submarine race, whose finale would be nuclear giants capable of hiding in the ocean abyss from any nuclear apocalypse. Part 1. The man who invented the pedal-powered fleet. Chapter 1. Odessa, 1876, a bicycle for the Tsar father. To understand the genius of Stepan Dzhevetsky, known in the West as Stefan Drzewiecki, we must forget everything we know about modern submarines. Forget diesels, nuclear reactors, missile silos. We must transport ourselves to an era of crinolines, horse-drawn trams, and the nascent bicycle. In 1876, in the port workshops of Odessa, an atmosphere of secrecy and curiosity prevailed. Here, under the guidance of a 33-year-old engineer, something unprecedented was being built. Dzhevetsky was no armchair scientist. He was a Renaissance man, a mechanical engineer, inventor, and, importantly, a friend of the famous artist Ilya Repin. Repin is said to have based one of the characters in his painting Reply of the Zaporozhian Cossacks on Dzhevetsky. But his main passion was the question, what if a ship could submerge? The idea wasn't born in a vacuum. The Russo-Turkish War, 1877 to 1878, was on the horizon. Dzhevetsky, a Pole by origin serving the Russian Empire loyally, was seeking an effective way to combat the Turkish armored fleet. The artillery of the time was powerless against thick armor. Mines were passive. He needed a weapon that could approach the enemy on its own. And Dzhevetsky proposed a boat. But what a boat! Its main propulsion system was legs. Yes, the first tests were conducted on a boat powered by a bicycle drive. 4 men inside the boat pedaled, turning a propeller. This sounds comical now, but then it was ingenious. Dzhevetsky reasoned simply, muscles are the most accessible, quietest, and most reliable engine. A steam engine needs air underwater, it smokes and makes noise. Electricity meant expensive and imperfect batteries, but 4 healthy sailors could pedal for hours, the only sound being the gurgle of water past the hull. The first model, built in Odessa, was a one-man rubber inflatable boat. Yes, essentially, it was a huge underwater quote, _5 _ made of rubberized fabric. But Dzhevetsky didn't stop there. In 1877, he built a full-sized metal boat. It was tiny, only about 4 meters long. The crew was one man. The propeller was turned by pedals. The boat dived by filling a ballast tank with water and surfaced by blowing it out with compressed air from a hand pump. And then came an event that sealed Dzhevetsky's fate. In 1877, while Russian troops were fighting in the Balkans, Dzhevetsky decided to demonstrate his boat to the commander-in-chief, Grand Duke Konstantin Nikolaevich. The location was the Odessa roadstead. Approaching the admiral's barge underwater unnoticed, Dzhevetsky attached a mine to its bottom. Then he surfaced right in front of the astonished admiral. If this had been a real battle, the flagship would have been destroyed. The effect was staggering. The Grand Duke immediately ordered further work. Chapter 2, 1881, The Birth of the Dzhevetsky. After the war, Dzhevetsky continued to refine his design. He understood that a one-man boat was a toy. A real combat ship was needed. Thus was born the project that went down in history as the Dzhevetsky Submarine of 1881. This was no longer a small craft, but a quite serious machine for its time. Here is what it looked like. Hull. All metal, riveted, streamlined. Length about 5.7 meters, beam about 1.5 meters, submerged displacement about 4.5 tons. Crew, 4 men. They sat inside like rowers in an ancient galley. Engine, manual. 4 sailors turned pedals connected by a chain drive to the propeller. Underwater speed was laughable by modern standards, about 2 to 3 knots, roughly 4 to 5 kilometers per hour. But it was enough to quietly creep up on a sleeping enemy in a port or roadstead. Armament. Here, Dzhevetsky took another revolutionary step. His boat carried 2 mines, a prototype of the torpedo attached externally on special mounts. The boat would dive under the enemy ship, the mines would press against its bottom, and a mechanism would activate. Later versions used pyrotechnic tubes detonated by a galvanic element from inside the boat after it had moved to a safe distance. This was a fundamentally new approach, not ramming, not broadside artillery, but a stealthy attack from the deep. In 1881, Dzhevetsky demonstrated his boat at Gatchina, on Silver Lake, before Emperor Alexander III and the entire imperial family. Picture the scene. An idyllic landscape, the imperial yacht on the water, when suddenly a strange whale emerges from the depths, approaches a target raft, and sinks it with a dummy mine. An explosion, a fountain of water, the public's delight. The emperor was so impressed that he made a decision to order 50 such boats from Dzhevetsky for the defense of the Black Sea ports and Kronstadt. This was the world's first series production order for submarines. Russia had outpaced everyone by decades. However, this order also had dramatic consequences. The boats were built hastily at different factories. Quality suffered. The pedal drive, fine for calm weather, proved helpless against currents. The sailors of that era, raised on sails and armor, viewed the submarines with ridicule. They were called underwater filly and sardine tins. Ultimately, by the mid-1880s, Dzhevetsky's boats were given away. Yes, they were disassembled and sent to ports as training aids and floating mine stations. Some boats were converted into torpedo boats, surface craft. The idea of a submarine fleet was temporarily abandoned, but the seed had been sown. Dzhevetsky himself did not stop. He emigrated to France, continuing to work on submarines, creating projects with gasoline and electric engines. His ideas were used by other designers. and his wooden and metal .11 quietly rusting in ports became the first teachers for a whole generation of Russian miners and mechanics who would later, in 1914, aboard other boats, make history. Part 2. The Long Shadow of the .12, Evolution in Wars, Chapter 3. From Pedals to Kerosene, The Missing Link. Dzhevetsky's Philly were already obsolete by the 1890s, but the fact of their mass production gave Russia a unique experience. It turned out that building submarines was possible, and that people could live and work underwater. In the 1900s, when the whole world rushed to build submarines, thanks to the invention of the Whitehead torpedo and the appearance of reliable internal combustion engines, Russian engineers were no longer starting from scratch. They remembered Dzhevetsky's experience. Boats like the Delphin, 1903, Kasatka, 1904, and Akula, 1909, were real combat ships. They ran on gasoline, later diesel engines on the surface, and electric motors submerged. They still carried the ___, _14, ___, a love for the simplicity and reliability of certain components. Then came the Russo-Japanese War. In this war, submarines went on combat patrols for the first time, albeit without significant success. But crucially, they frightened the Japanese. Rumors of Russian submarines that could appear from nowhere hampered the Japanese fleet's operations off Vladivostok. Chapter 4, 1914, The Hour of U-9 and Britain's Reckoning. And so we return to that September morning in 1914. What did Otto Weddigen do? He invented nothing new. His boat, U-9, was a typical vessel of its time. Diesel-electric, displacing about 500 tons, armed with torpedoes. But he did what Dzhevetsky had foreseen. He struck from where he wasn't expected, using stealth as his primary armor. The sinking of Aboukir, Cressy, and Hogue shocked the world. British admirals, who only yesterday considered submarines the weapon of the weak and an ungentlemanly way of warfare, understood in an instant the old era was over. The giant battleships, requiring thousands of sailors and tons of coal, had become mortally vulnerable. A small boat, which could be built in a small shipyard in a few months, could send the pride of a nation to the bottom in minutes. Paradoxically, England, paying with blood for its arrogance, learned the lesson. It was the British who, during WWY, built some of the best submarines and the most effective anti-submarine warfare systems. But the train had already left the station. Chapter 5. World War II. Wolf packs and convoys. By 1939, the submarine had become the full master of ocean communications. Germany's diesel-electric U-boats, under the command of Karl Dönitz, unleashed the Battle of the Atlantic. They no longer operated alone, but in .18, attacking Allied convoys at night. The boats had come a long way from Dzhevetsky's concept. They were huge, up to 1,000 tons or more, had powerful torpedoes, and could travel thousands of miles. But the essence remained the same. Dive, hide, strike from the depths. The Germans perfected the tactic of nighttime surface attacks, using diesels for speed, submerging only when danger threatened. And again, as in 1914, the submarine proved it could bring a great power to its knees. England was on the brink of starvation. Merchant fleet losses were terrifying, but a counter was found. Radar, sonar, ASDIC, long-range aircraft, heavily escorted convoys, breaking the Enigma code, all of this broke the back of the German submarine fleet by 1943. It turned out that the submarine was vulnerable precisely where it was strongest, in the need to surface. To surface to charge batteries, to ventilate the compartments, to make speed. Underwater, the diesel boat was slow and blind. Designers frantically sought solutions. Schnorkels appeared. tubes for running diesels underwater, boats with a whale-shaped hull for increased underwater speed, Type 21. But it was too late. The war ended, and then a new force entered the stage. A force that turned Dzhevetsky's dream of an quote, _20 ship into reality. This force was called the atom. Part 3. The Nuclear Abyss. How the Atomic Heart Returned the Boat to its Element. Chapter 6. Water instead of armor. Your query contains a very accurate phrase. Quote, _21, yes. In the 1950s, this dispute reached its peak. Nuclear bombs appeared, capable of destroying entire fleets. Missiles appeared that could carry this horror thousands of miles. Aircraft carriers and battleships seemed to become giant targets. Their armor was useless against a nuclear explosion. And then a miracle happened. Nuclear energy, which created the ultimate offensive weapon, also gifted the ship with absolute defense. A nuclear reactor requires no air, none at all. It can run for years, providing heat and energy. The submarine, receiving an atomic heart, ceased to be a quote 22. It became a submerged ship in the fullest sense of the word. It can travel at 30 knots, 55 kilometers per hour, underwater for weeks. It can descend to depths of 400 to 600 meters beyond the reach of any storm or aircraft. It only needs to surface to change crews and provisions. The many meters of water above the boat, that is its armor. Water dampens the shock wave, absorbs radiation, hides it from radar and satellites. The nuclear submarine, SSN/SSBN, became the ultimate weapon of retaliation. Chapter 7. Nautilus and its descendants. The world's first nuclear-powered boat was the American USS Nautilus, SSN 571, launched in 1954. It bore the name of Jules Verne's fantastic ship. This was symbolic, as Jules Verne himself had been inspired by the first real submarines, including Dzhevetsky's projects. The circle was complete. Nautilus proved. A boat could travel under the ice of the North Pole. It could stay submerged for months. The world entered a new era. Following the USA, the USSR built its nuclear fleet. Engineers who had started by studying captured German boats and Dzhevetsky's blueprints now built titanium giants capable of reaching depths where water pressure would crush steel like foil. Chapter 8. Missiles. Underwater, the final verdict on the surface fleet. The next step was inevitable. If a boat can stay underwater indefinitely, why not arm it with ballistic missiles? Thus were born strategic nuclear-powered missile cruisers. In the USA, the George Washington class. In the USSR, Project 658, then 667, and 941 Akula/Typhoon. Now the submarine had finally taken first place in the naval hierarchy. It moved from the last pages of naval reference books to the first. It was the submarines, lurking in the depths of the world's oceans, that became the main guarantors of the Cold Peace. Because it is impossible to destroy all of an enemy's submarines in a first strike, the survivors would launch their missiles in retaliation. This was called, quote, 24 armored ships, battleships, heavy cruisers passed into history. Their place was taken by quote, _25, silently gliding in the blackness of the abyss. Epilogue. A light in the ocean. 100 years separate Dzhevetsky's wooden pedal boat, pedaled by 4 sailors on a Gatchina lake, from the Project 955 Boré-class nuclear-powered ballistic missile submarine, carrying 16 intercontinental missiles capable of wiping an entire continent off the face of the earth. What do they have in common? The commonality is the very idea. The idea of stealth, surprise, using the ocean depths as the main ally. Dzhevetsky was the first to prove that man could live and fight underwater. He was the pioneer who blazed the trail into an unknown world. Now, when we look at photos of the first boats, those funny toy-like mechanisms, we must not laugh. We must tip our hats to those lone madmen who, in stuffy, smelly, cramped boxes, pedaling and drenched in sweat, proved to the world. A ship can go underwater to return and win. Their pedal filly gave birth to the whales of the atomic age, and the water still presses against a submarine's hull, hiding it from enemies, just as it pressed against the hull of Dzhevetsky's boat in 1881. For the ocean is one, and the laws of stealth within it are eternal. Author's note: this text represents an attempt at artistic documentary reconstruction. S.K. Dzhevetsky's fate was tragic. His invention, ahead of its time, did not find proper application in his homeland, but he remains in history as one of the fathers of the submarine fleet. And when, in the autumn of 1914, English sailors were drowning in the icy waters of the English Channel, they cursed German cunning, unaware that the technical foundation of this cunning had been laid 30 years earlier in the quiet Russian lakes by an engineer with a Polish surname.